Okay, so today I'm going to show you how to do solving distance, rate, time problems using a system of linear equations, okay? This might be maybe my favorite objective of this favorite topic of this objective. So we'll take some time, we'll see if we can get through this and kind of give you some information on how to solve this kind of problem. Okay, so what you're going to notice when you look at this, you got two buses that leave the station at the same time. They're traveling in opposite directions. One bus is going 17 miles per hour faster than the other. If the two buses are 1,350 kilometers apart after 6 hours, what is the rate of each bus, okay? So what you need to know is distance, rate, time always is d equals, the distance is equal to the time times the rate. So distance equals time times rate. So what we need to do is we got to figure out which variable we're solving for. So that always comes either in the boxes below where it says what your answer looks like, or usually in your last sentence. So if you look here where it says what is the rate of each bus, rate, that's the key word there. What is the rate? So R is going to be my variable I'm trying to solve for. So what I'm going to do is I'm going to use X and Y. I'm going to say X is going to be equal to the rate, because it says rate on the last, that's what I'm trying to find, of the first bus. So first bus, okay? And then Y, here, let's use a different color. Keep it all together. Okay, so Y is going to be equal to the rate of the second bus, okay? So that's their rates, okay? So maybe draw a little picture so you can kind of visualize it. You got, what do we got? We're leaving the train station. Here's my train station right there. Yeah, it's lovely. Okay, you got a bus right here. He looks like that. That's my bus. Okay, and you got another bus over here. Okay, and two wheels and one windshield. Yeah, you get it. Okay, so one bus is going this way, one bus is going that way. One's going a little bit faster than the other. Okay, so let's think about it. Let's see if we can make some equations off of these sentences. It says the two buses leave the train station at the same time, traveling in opposite directions. One bus, it goes 17 miles per hour faster than the other. Okay? So if you think about that sentence right there, how can we write an equation for that? Well, they're talking about their speed. So if you think about it, the one bus, which we don't know which one's which, so it doesn't really matter. Why don't we just call it x? We'll say x is equal to, okay, y, okay, um, minus 17. So if we're assuming that y is the faster bus, if you take 17 away from them, they should be equal in rates. Okay, it would have also worked if you would have chose x to be the faster bus and switched, it would have been the same. So I'm saying the buses rates will be the same if I take 17 away from the faster bus, which I'm just going to call y. Okay, now we're on to the second sentence. So let me get my green highlighter out here, and we'll talk about that. So if you have two buses that are this far apart after 6 hours, okay, well, that's a whole problem right there. So if they're that far apart after 6 hours, well, how do we calculate distance? Well, we know right here distance is equal to rate times time. Well, rate is our variable. So how are we going to represent that? We're going to say our distance, or um, 1,350, is going to be equal to the rate of the first bus times the time. So my first bus is x times the time that how long he was going. Well, he was going for 6 hours. So if he was going 6 hours at a certain rate, that would give us a distance. Now, if I add the rate of the second bus, which is y, right? And multiply it by his time, which is 6 hours. So I got 6 hours at the first rate and 6 hours at the second rate, which will give me the distance for the first bus and the distance for the second bus. If I add them together, I get my total right here. Okay, so that's what I want. Now, all the hard part is done. You are done with the hard part, and now we move on to the easy part, which is simply just solving this equation. So you've got choices here. You can, well, if you want to do substitution, you can do substitution. But me, personally, I'm going to do graphing. So if I type this in, let me get my two equations over here. Here we go. Okay, so we got x equals y minus 17. And we have 6x plus 6y should give me a total distance of 1350. Okay, you can see on Desmos right here, we have it open. This is the point where it crosses. I get 104 and 121. So those would be my two rates. So yeah, that's your answer, and you're done. Okay, so your answer would be, let me go back to this, blow that up a little bit, 104 and 121. So x would be equal to 104, and y would be equal to 121. That would be the fast bus, and this would be the slow bus. Okay. And there you go, you're done. So the key in this problem is to know what you're trying to solve for. Know your variables right off in the beginning is the most important part, and that usually comes from that last sentence, like we talked about earlier. Okay, good luck.